Hello, my name is Afiq Behelmi. I'm from AS1202A. Today I will explain about lactic acid related to muscle cramp for my case study in BIO150. For introduction in this topic, anaerobic respiration, which is how cells make energy without the presence of oxygen, produce lactic acid, also known as lactate, as a chemical byproduct. It is made in yogurt and our intestines by bacteria. Our blood also contains lactic acid because red blood cells and muscle tissue deposit it there. Higher than normal lactic acid levels can lead to a condition called lactic acidosis. If it's severe enough, it can upset your body's pH balance, which indicates the level of acid in your blood. Lactic acidosis can lead to these symptoms such as muscle weakness. My problem statement in this topic is our body produces lactic acid when we lack of oxygen. But how to prevent lactic acid happen in our body, and what are the symptoms lactic lead to? For discussion, the first question is, where does lactic acid come from during vigorous exercise? My answer is when there is a high energy demand, frequent variations in the energy demand, and a deficiency in oxygen, lactic acid is created and builds up in the muscle. Muscle pH drops to about 6.4 and 6.6 with prolonged severe exercise. For second question, what is the difference between aerobic and anaerobic respiration? My answer is aerobic respiration takes place in the presence of oxygen, but anaerobic respiration takes place in the absence of oxygen. The second one is aerobic respiration produces a lot of ATP per glucose molecule, but anaerobic respiration produces less ATP per glucose molecule. The third one is aerobic respiration occurs in the mitochondria of cells, but anaerobic respiration occurs in the cytoplasm of cells. The last one is aerobic respiration. Less energy is produced, but anaerobic respiration, a lot of energy is required. The third discussion is, what is the final electron acceptor in aerobic respiration? The answer is the final electron acceptor is acceptor for the electron transport chain in aerobic respiration is an oxygen molecule. O2. Oxygen is the final electron acceptor in this respiratory cascade, and its reduction to water is used as a vehicle by which to clear the mitochondrial chain of low energy spent electrons. The enzyme that catalyzes this process, cytochrome oxidase, spans the mitochondrial membrane. The fourth discussion is, why is lactic acid formed even when the athlete is breathing oxygen? When an athlete works out, their body converts glucose to energy by using oxygen. When exercising hard, there might not be enough oxygen available to finish the process. Hence, lactate is produced. This lactate may be converted by your body into energy without the need of oxygen. And for the last discussion, does gender and body size affect accumulation of lactic acid? Why or why not? The answer is the accumulation of lactic acid does not depend on gender and body size, but on the intensity or amount of exercise completed. It also relies on how quickly lactic acid is absorbed by bodily tissues when it is created. So this is the references that I've been looking for find my information to answer the discussion. There are 5 references in format APA style. For my conclusion, our body is naturally occur lactic acid if we don't have enough oxygen in our body. There is no other way to prevent lactic acid because your body naturally gets rid of lactic acid through metabolism. Taking deep breath, staying hydrated, and reducing exercise intensity are the best ways to maximize natural lactate clearance. We must know the symptom of lactic acid is body weakness, exhaustion, or muscle cramps. And that's all for my case study. lactic acid related to muscle cramp, and thank you.